All right, so these are our notes for predicting products. So if you don't have your Cornell Notes template open, go to Classroom, go to Classwork, okay, and it's down in the Chemical Reactions unit, and you want to click on Predicting Products Notes, and there is your copy of the Cornell Notes template. All right, so let's go ahead and get started, okay? All right, so predicting products of chemical reactions. We've talked about now how to identify reactions. We've talked about how to balance reactions. We're going to use both of those when we go into predicting, okay? So our essential question for these notes are, how do I predict the products of a chemical reaction? Okay, so a little bit of review. What are the 5 types of reactions and what happens in the reactions? Those are pretty important as we get to prediction. Remember, we've got a synthesis where 2 reactants combine to make 1 product. We have a decomposition where we have 1 product breaks down into 2 or more products. Not products, but it should be 1 reactant breaks down into 2 or more products. Let me go back and fix that one. All right, I think I got that fixed. So again, we have our synthesis, but our decomposition is 1 reactant breaks down into 2 or more products. Our combustion is a hydrocarbon. That just means it has hydrogen carbon. Carbon plus oxygen react to yield carbon dioxide and water. Those will always be the products for combustion. A single replacement is where a single element replaces another element in a compound. So they switch places. And remember, cations can only replace cations, and anions can only replace anions, okay? You can't have a cation replace an anion, okay? Positive can't replace negative. And number 5 is a double replacement. That's where the cations switch places in the molecules, and so the cations switch partners, okay? All right, so let's get started. All right, there's 4 steps when we're predicting. The first step is you're going to determine the type of reaction. And then the second step is predict the products. You may need to crisscross. And then step 3, remember crisscross is for ionic compounds. Step 3 is write the complete reaction. And then the last step will be to balance it. Okay, so let's look at example number 1. So we have what you see here, a hydrocarbon. It has hydrogen and it has carbon. It has some oxygen too. But then we're going to react it with oxygen. So we're going to determine the type, and that would be combustion. So this is going to be a combustion. And remember, combustion, we don't have to do any crisscrossing. We don't have to do anything. We already know the products of combustion, and that is the products are only carbon dioxide and water. Okay? So then we'll write the entire equation here. You can see carbon dioxide and water here. Then you go ahead and you balance it. And so this would be, you would need 3 oxygens. And I did put a 1 here just to hold its place. It would be 1, 3, 2, 3 for a total of a balanced equation. Okay. All right, so let's look at another one. So here's another one. We have sodium plus chlorine. So what kind of reaction? We have 2 single elements here, and this will be a synthesis. So when we have 2, we don't have a molecule either anywhere here, so this would be a synthesis. And then we're going to determine the products. Remember how I said sometimes you have to determine, do you need to crisscross? Well, sodium is a metal, chlorine is a non-metal, so this will be an ionic compound, so we will need to crisscross, okay? So we're going to use crisscross to determine our products. So sodium is a +1, chlorine is a -1, so there's actually no need to crisscross as they are the same, so you just need 1 of each. Also notice as this is written, this says Cl chlorine and it has a 2. Remember, chlorine is one of our 7 diatomic ions, okay? And so then you will write the equation, and so sodium plus chlorine will give us sodium chloride, which is salt. And then the last step will be to balance it. And you need to add a 2 in front of sodium and a 2 in front of sodium chloride to balance. Okay? All right, let's look at another example. So here's one, and I'm telling you that you have copper chloride here, and it's just 1 reactant. So when we just have 1 reactant, that would be, take a minute, which type of reaction? Hope you said decomposition. So it's going to decompose into the two actual separate elements, okay? And then you're going to determine the products crisscross if needed. But you will know that it'll split up into copper and chlorine. And again, notice I put a 2 on chlorine because it is one of our natural diatomics. Those are our 7. Remember, it makes that number 7 over on the right side of the table and plus hydrogen. So it is a diatomic. Then you will write the complete equation. So copper chloride will break down to copper and chlorine. And then the last step will be to balance it. Okay, and you need to put a 2 in front of copper chloride and a 2 in front of copper. All right, let's look at another example. So here we have aluminum plus barium chloride, and notice we have an element and a molecule. So we have one where we have a bond here, we have a molecule, and then we have a single element. So what type of reaction would that be? Well, I sure hope you said single replacement. So our aluminum is going to come in and take the place of our barium and determine the products crisscross if needed. So let's determine if we need to crisscross. Well, we have aluminum, which is a metal, and we have barium, which is a metal, and chlorine, which is a non-metal. So this will switch. This is already an ionic compound here with barium, a metal, plus chlorine, a non-metal. And we're going to replace barium with another metal. So again, this is going to be an ionic compound. So we will need to crisscross, okay? And so aluminum is a +3, chlorine is a -1. Again, our 1 will go over to our aluminum. The 3 will go over to our chlorine. So the neutral compound will be aluminum chloride, which is 1 aluminum, 2, 3 chlorine, okay? And again, our barium would jump out. Now notice I did not put a 2 on barium because it is not one of our 7 diatomics. Okay. And then we'll write the complete equation. We have aluminum plus barium chloride leads to barium plus aluminum chloride now. And then our last step will be to balance it. So you would have a 2, 3, 3, 2 to balance. Okay. All right, let's look at one of our last examples here. So now I have an equation. I'm starting with sodium chloride and aluminum oxide here. Notice I have 2 compounds. So what kind of reaction would that be? Well, I sure hope you said double replacement. So this is going to be a double replacement, and our aluminum and our sodium are going to switch places. Notice sodium is a metal, chlorine is a non-metal, so this is ionic. Aluminum is a metal, oxygen is a non-metal, this is also ionic. So when our 2 cations here switch places, these will make ionic compounds. So we are going to need to crisscross. So we're going to go ahead and do that. So the first one is sodium Na is now going to take up with oxygen. So sodium is a +1, oxygen is a -2. So the 2 will go over to sodium, the 1 over to oxygen. So our new compound will be sodium oxide, 2 sodiums to 1 oxygen. But then we also now have to do aluminum with chlorine. They're going to switch places. So aluminum, like we did in the last one, is a +3. Chlorine is a -1. We will send those numbers to the other side there, and you'll get 1 chlorine or 1 aluminum to 3 chlorine. Okay? So those will be our new products. Na2O plus aluminum Cl3, AlCl3. Okay. Then you go ahead and you write the complete equation. So you write your reactants, which are up at top here, sodium chloride plus aluminum oxide, yields sodium oxide plus aluminum chloride. And then you will balance the equation, and you need 6, 1, 3, 2 to balance the equation. Okay. All right, so those are the end of the examples for each of the types of chemical equations. So go back, highlight any important notes. You're going to make connections to any of your notes in the left-hand column. Write any questions you may have in the left-hand column. Use your highlights, connections, and questions for your summary. And then in the end, write a 3 to 5 sentence summary. If you guys have any questions, please do not hesitate to ask.